Good morning, DSST students, and welcome back to lesson 3.3, Change in Experiments. Today we're going to be taking our learning from last lesson about physical and chemical changes, and we're going to be taking it one step further. Now, I hate to say this is a tricky lesson to take to a virtual space like this. This is absolutely a lesson we would love to have you in class where we could do some demonstrations and do some experiments with you in person. Today we're going to have to use a video instead to show what we're talking about. However, you will continue to learn about this in chemistry in high school and hopefully have a chance to do some really cool simulations about physical and chemical change. So today we're going to be learning about how do you know if a chemical change occurred simply by looking at experimental data. So data you can collect about substances before a reaction and after a reaction to determine what happened. Let's go ahead and jump into guided instruction. You should have already finished the do now, the review practice, and the explore section of today's lesson. So the question I have is, how do I know if a physical or chemical change happened if I can't see it and I can't see the atoms? So I can't see if a change happened. There wasn't a new color, there wasn't a new smell, there wasn't a new gas produced that I could see. How do I know if a chemical or physical change happened? This is pretty common, actually. For example, what happens if I mix two clear liquids together and then I'm sitting there staring at a beaker with clear liquid? How do I know if it's a new compound or if it's the thing I started with in the first place? Well, the way we do this is by analyzing properties. The definition of a property is a characteristic of a substance. Okay? There's a lot of different properties we talk about in science class. Could be the temperature, could be the state of matter, could be the mass you have or the size. But we're going to be talking specifically about intrinsic properties today. So an intrinsic property is a property that is always the same for a substance in the same conditions. It's always the same. So for example, water, pure H2O, at room temperature, water is always going to have the same boiling point. Water is always going to boil when you get to 100 degrees Celsius or 212 degrees Fahrenheit. I don't care where you are on planet Earth. If you have pure water, it is going to be boiling in the same place, okay? Now, there are some caveats to that. Some people say, well, actually, what about if you change? Well, if you're always in the same conditions, it's always going to behave the same way. It doesn't depend on how much you have. So if I had 2 gallons of water I was trying to boil on my stove, or if I had a tiny little cup of water, either way, when it gets to 100 degrees Celsius, it's going to start boiling. Does not matter how much of that water you actually have. Doesn't matter the volume, doesn't matter the mass. It is always going to boil. So that is an intrinsic property. Here's some other examples of intrinsic properties. First is density. Density is how much matter is packed into a given amount of space. Okay? A good example of this is gold. Solid gold, pure gold, no matter how much of it you have, is always going to have the same density. Okay? And so if it always has the same density, you can test a substance to know if it's pure gold or not. So if you go to a jewelry store and you want to know how many carats or how pure the gold is, okay, pure gold is going to have the same density. So that person can test the density right there in front of you, and they can determine if it's pure gold or not. Okay? So that's an intrinsic property. The second one is melting point. Just like I talked about with water, with a boiling point, melting point is the temperature when a substance changes from a solid to a liquid. So water is always going to change from solid water, ice, into liquid water at 0 degrees Celsius. That's its melting point. If it's pure water, if it's pure ice, it's always going to melt at the same temperature. That is an intrinsic property as well. Boiling point we already talked about, the temperature when a substance changes from a liquid to a gas. The last one is odor. The smell a substance gives off, as long as it's a pure amount of that substance. That would be different if it was a mixture. Okay? So if you mixed something that smelled into water, that's no longer pure water, so it would have a different odor. We're talking about just the pure substance by itself. Now, the key idea here is that if we can measure the properties, these intrinsic properties of an unknown substance, we can figure out what it is. So if we do a chemical reaction, we mix things together and we end up with something that we don't know what it is, well, we can measure the melting point. We can measure the boiling point. We can measure the density. We can check the odor. And we should be able to tell if that, or we can find out what that new substance is. We can compare it to other experimental values of known substances, and we can figure out what it is. So this is a very helpful way to figure out if a physical or chemical changed, if something's microscopic and we can't see one of those obvious clues we talked about yesterday. Now, let's go ahead and jump over to guided practice to take this learning and put it into some practice problems. So here's our first practice problem. Miranda placed two liquids into a test tube, liquid 1 and liquid 2. She recorded data about both liquids in the data table below. She mixed the liquids, then heated the test tube. After heating the liquids for 5 minutes, she measured some properties of the liquid in the test tube, recording the data in table 1. So she didn't see a change, but she's curious to know if there was a physical or a chemical change. So let's look at the data table. Well, our first row is before we heated. We had liquid 1 and liquid 2. Gives us the volume, the amount of space that liquid 1 took up, the smell or the odor, the boiling point, the density, and the temperature. She does the same for liquid 2. And remember, those are the two things we started with. And then after she heated, after she mixed and heated, she has this unknown liquid. We've got its volume, we've got its smell, we have its boiling point, we have its density, and we have its temperature. I want you to take a moment and think about which of these properties would actually be the most helpful in determining if a chemical change happened. Let's go one at a time. Let's first look at volume. Volume is the amount you have of a liquid. So that really doesn't tell us anything. If I have a small amount or a big amount, that doesn't tell me if it's one compound or a different compound. The second one, though, is a clue. The new liquid, or the liquid that after she mixed and heated it smells fruity, which is different than both of the liquids that she put in. So that could be a clue that we had a chemical change. Let's look through the rest of them. A boiling point, that's an intrinsic property. So the thing she ended up with has a boiling point of 100.1 degrees Celsius. That's different than the two liquids she started with. So that's another clue that a chemical change happened, that this is a new compound we made. And the density is also different. It's 0.90 grams per centimeters cubed. That's different than the densities of the first two substances she started with. The last column is temperature. Well, temperature doesn't tell us anything. All it tells us is that she's recording this data at the same temperature. So that tells us, well, that this new liquid is a new liquid. So yes, a chemical change did occur. And what evidence supported our answer? The unknown liquid had a different smell, boiling point, and density than the initial two liquids. So thinking back to yesterday, that means that the product, this new liquid, has different properties than the reactants. That should tell us it's a new compound that was created. Bonds were broken and new bonds were formed to make a new compound. Let's see another practice problem that you could be asked about. Question 2. A scientist was conducting an experiment using different liquids. They mixed two clear liquids together. She saw a gas spring produced, so she knows there was a chemical reaction. However, she doesn't know what the new liquid is. She collected information about the unknown liquid in the table 1. Compare the data in table 1 to common products in table 2 to determine what the unknown liquid is. Okay, so this time we know there's a chemical change. We're just trying to figure out what is the substance we ended up with. This is another very common thing we can do in a chemical or in an experiment. Let's look at our unknown liquid. It gives us their mass, gives us the volume, gives us the density, which is 1.05, gives us the odor, gives us the color, gives us the melting point, and gives us the boiling point. Okay, and then our data table, we've got for ethanol, we've got water, we have vinegar, and it gives us all of the same properties. I'm going to take a moment and try to think about which properties would be most helpful here. Well, I know mass and volume, how much it weighs and how much space it takes up. That's not really helpful because you can have a different size of the substance. The density could be a good clue. Odor could be an intrinsic property. That could be a clue. And the melting and the boiling point could also be. Color, unfortunately, everything's clear, so that's not a good clue for us. Let's go ahead and look at it. So we started with something with a density of 1.05. Well, it looks like vinegar also has a density of 1.05. The odor is acidic. The melting point is 16.6 degrees Celsius, and the boiling point is 118 degrees Celsius. So that means the unknown liquid is vinegar. The evidence that supports my claim is the density, odor, melting point, and boiling point are all identical. So now you can see a couple different ways where we can use intrinsic properties to figure out if a chemical change happened or a physical change happened. Also, we can use that understanding to figure out what an unknown substance is. I want you to move ahead and try the check for understanding. Go ahead and pause this video and resume when you're ready to go through the answers together. At this point, you should be ready for the answer key. So in this check for understanding, a student mixed a solid and a liquid together, they heated the beaker, and then they recorded the properties of the substance and recorded it below. So the reactants are in data table 1. We started with a liquid and a solid. The products are in data table 2. Looks like we ended up with a different mass and a different volume. However, the densities for the liquids were the same, and the density for the solid was the same. The odor was none for all of them. The color of the starting and ending liquid were the same, and the color of the starting solid and ending solid were the same, and the melting point and boiling point matched for both the liquid and the solid as well. Therefore, no, a chemical change did not occur. And the evidence that supports this? Well, the density, odor, melting point, and boiling point stayed the same, which means the products are the same compounds as the reactants. So no, a chemical change did not happen. Give yourself a score out of 2 if you got both parts of that question correct. Then you're ready to move on to independent practice and move on to your mastery check.